This is the explanation of number 2 from the 2018 International Free Response Problems. So in this problem, they give you the velocity of a snail, and they want the acceleration at time 5. Well, we know that acceleration is equal to the derivative of velocity, and so basically I can differentiate this one by hand. 1.4, the derivative of ln is 1 over the thing, d thing. So the acceleration at time 5 would simply be 1.4, 1 over 1 plus 5 squared times 10, otherwise known as basically 14 over 26, and you get the answer of 0.53846. This is the velocity is in inches per minute, so this would be the derivative, which is inches per minute squared. They did not ask you for units, but it's not a bad thing to include them at that. And remember that they want at least 4 place accuracy. So if you wanted to, that's at least 3 place accuracy, and that's at least 4 decimal places. You could even go to that extra step there. So there's the answer to 2A. Part B asks for the displacement. We know that displacement is equal to the integral of velocity, and so we simply would have to integrate that function from 0 to 15, and the function was that 1.4 ln of 1 plus t squared dt. This is not something you could differentiate by hand. You would have to use Math 9. Therefore, this will not be a question that they would ask you on this year's AP, but the answer ends up being 76.04307. Remember, in Math 9, it asks you to type in these two numbers, that number, and of course that value of the variable. So make sure you remember how to use Math 9. You're allowed to use it, but they're not going to require you to use it. In any event, if you're integrating inches per minute times minutes, this would be in inches, is the answer to part B. In part C, they want to know when the instantaneous velocity is equal to the average velocity. Well, the average velocity would be displacement over time. In other words, the answer we just had a second ago, that 76.04307, divided by the change in time, which would be, of course, 15. So average velocity is change in position over change in time, and change in position is otherwise known as displacement. In any event, that number ends up being 5.069538, and so they really are asking you to solve this equation. Again, not something that you have the ability to do very easily by hand, but you could use your solver key, and when you use your solver key, the value that makes that true is 6.031468 minutes. Again, they only want 3 place accuracy, but that's the answer to a little bit better accuracy than that. And then we get to the very confusing number D. So now you have an ant who's going to basically start where the snail started, but start later and eventually catch up. So when they catch up, the snail and the ant have traveled the same distance. So what is the displacement of the ant? Well, in order to figure out the displacement, what do I know about the ant? I only know one thing, that the acceleration is equal to 2. So the acceleration of the ant is equal to 2. That means the velocity of the ant is the integral, which would be 2t plus some constant. So that's what I know so far about that ant. So how far did that ant travel during the time it was trying to catch up to the snail? Well, that would be the integral of velocity. So if I integrate 2t plus c, and I do it for the 12 to 15 minutes, this will give me the displacement of the ant during that traveling. And that would be, of course, t squared plus ct plus some under the known constant, and now plug in 15 and 12. And when you do that, you end up getting 225 plus 15c plus d minus, when you plug in 12, you get 144 and 12c plus d. And if you subtract these from each other, you end up getting 81 plus 3c. That's how far the ant traveled. But that's got to be the same as how far the snail traveled. And that was the snail's displacement from 0 to 15, how far it traveled. And we already figured that out earlier in the problem. That was that 76.043 inches. And if that equals 81 plus 3c, trust me, you can do the arithmetic here, and it ends up that c value ends up being, I believe, negative 1.65231. So what's all the takeaway with that? Well, now I know exactly what the velocity of that ant is at any given moment. The velocity of the ant is 2t minus 1.65231. That's the velocity of the ant. And all they asked you was, tell me the velocity at time 12. So it's going to be, when you plug in 12, 24 minus 1.65231, which ends up being, I believe, 22.347669, roughly. And they said it's b inches per minute. Basically, that's your b value right there. This problem was quite involved, but basically what they wanted you to know is that if I give you acceleration as some constant, the velocity is the integral of that with some unknown number, and the displacement would be the integral of that. So just showing off you know those things.